All right, so I thought I'd put together this video, send this out to you because I couldn't attend Class Connect today. I'll explain it tomorrow when I see you. So today is the start of a new semester, and we're talking about work and machines. And our learning targets are as follows. I can identify when work has occurred, and I can calculate the amount of work completed. So we're going to deal with this concept of work in science today. And to help define that, I posted up this picture, and it says, "This boy has been trying to push down the wall for 20 minutes. Is he doing a lot of work?" So he's pushing, he's breathing heavy, he's sweating, he's out of breath, he's starting to fatigue, his muscles are straining, but is he doing work? The correct answer would be no. He is not doing any work according to our scientific definition. And our scientific definition is that work is when we are using an applied force to make an object move. And in this case, the important word is move. So in this slide, you can see an example of a person, I guess, pushing a crate across the slide. And in that top instance, there is work being done because the crate is moving from one place to another. But in our example of the boy pushing the wall, no work is done because there is no movement. If there's no movement, there is no work. So, again, work is when we use an applied force to make an object move. And my question is there a force applied? Well, yes, a force is applied. All right. Is there movement? Oh, no, there is no movement. So is there work? The answer is no, there is no work being done. So to remind yourself, if there's no movement, there is no work, according to our scientific definition. And so, as always, there is a calculation, there's a formula associated with it. Work equals force times distance. So let's say the boy is pushing with 1,000 newtons of work. He's really putting forth a strong force. But no matter how much force he applies, if the object doesn't move and we have zero distance, then no matter how big that force number is, if we multiply it by 0, then we get 0. Right? 1,000 newtons times 0 meters is equal to 0 joules, and that's the unit for work. 1,000,000 newtons times 0 is still going to be 0. So keep that in mind. Very important concept. If there's no movement, there's no work. And we measure work in a unit called joules. So here, which image below is an example of doing work? A, holding a 150 kilogram weight overhead. 150 kilograms, that's like, over 300 pounds. And she's holding it overhead. But she's just holding it there, right? Or 2, picking up a penny. Now, on the left, it's going to take a lot more effort and force to hold up that weight, but the weight is not moving. So technically, there is no work being done. However, on the right side, choice B, if you pick up a penny, even though it takes very little force and effort, you're making an object move. So the correct answer would be, B. B is the example where work is being done because there is motion in the object. All right, so when we look at this slide, choose which examples show work being done. So letter A, we have a person holding a bag of groceries, just holding it. B, we have someone running up a flight of stairs. C, we have someone pushing a wheelbarrow. And E, we have someone trying to push down a mountain, right? So which of the two will you see work being done? And the correct answer would be A and B. Let me change this up here. I'm sorry, B and C. B and C are examples where there is work being done because there's motion, right? There's movement going on in those examples. A, the person is just holding on to that bag of groceries. Nothing is moving. E, the person is really, really putting forth a lot of force, but the rock is not going to move. So B and C, we have movement. So B and C, there is work. All right. So again, our formula is work equals force times distance. Work equals F times D. So here we have a man carrying this crate, this 10 Newton crate, and he's moving it across for 50 meters, and he does it in 10 seconds. Well, the seconds aren't important for us right now. We just need to know force and the distance. So the work done is, the force is 10 newtons times the distance is 50 meters. So force times distance, that's going to equal 500 joules. All right, and so the answer is work equals 500 joules. And joules is named after this guy in the corner, James Prescott Joule. The unit for work is a joule. Let's try another one. How much work does it take to lift a 15 Newton box 2 meters off of the ground? So work, again, is force times distance. So the force is 15 newtons of force, and the distance is 2 meters. So 15 times 2, work is going to equal 30 joules. All right, so finally, this is my last slide. Work is when applied forces makes an object do what? So the definition of work is when a force makes an object, and I hope you got this one right, makes an object move. The next question, work equals blank times blank. Work is going to equal force times distance. And then this last one, I am not going to give you the answer for. You can tell me in class tomorrow how much work is needed to push a 500 Newton crate a distance of 8 meters. So we have a force and we have a distance. Work, formula for work is force times distance. All right. Thanks for watching. I hope you hung out for the entire time, and I'll see you guys tomorrow.